Do you know your basic exponent rules? Because you have to memorize the basic exponent rules before we start looking at those. Because these are like some of the basic rules that you need to know when you're timesing exponents, when you're raising an exponent to an exponent, or when you are dividing exponents. All right, so the basics before we look at those. When you have a power to a power, do you know what you do with those?
No.
A power outside a power. This is the only time you actually times those two numbers, right?
Yeah.
What happens when you're not raising it to a power? You're just
add.
Yep, you add them, right? And then what happens when you're dividing? Do you remember the rule? Because times plus them. Yep, but do you know the order that you subtract them?
No.
Is it the bottom number take away the top, or the top number take away the bottom?
The top?
Yep. That will give you 5 to the 8th power, right? All right, and then the last little basic rule I got to have you know, if you have a negative exponent, do you know how to make a negative exponent positive?
What did you like?
You put it over...
Yeah, you put it over something, and then you
put over one, and then you switch it. And then when you switch it, do you remember what happens? When you do the reciprocal,
it turns into positive.
Yep, that 1 goes to the top, and that 5 to the negative 2 is now 5 to the positive.
Right, because the next one you can't be like, yeah.
Right, so that's how you make a negative exponent positive.
Yeah.
All right, sweet, so good enough. So looking at those problems with all those exponents, is it starting here?
13.
On 13?
It starts in 13.
All right. So I'm looking at 13 right here. The only exponents I could even deal with are these x1s. You see that? So you're going to subtract that 12 minus 9 to get x to the third. Do you see that?
Yeah.
But then, do you see what to do with this negative exponent right here?
No, what do you do?
If you have something that's negative exponent on the bottom side of the fraction, if you flip it up and bring it to the top, it becomes positive too.
Oh, okay.
So what you do on this one is maybe do the x's first, because that would give you x to the 12 minus 9, x to the third power, right? I got that by doing 12 minus 9.
Okay.
And then see this y to the 7th?
Wait, why would you minus though?
Because anytime you're doing division, you're subtracting. Because really what happens there is you have 12 x's on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's x to the 12th. And on the bottom, you have x to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. So technically, these all cancel away. How many x's am I got left?
3.
Yep.
Okay.
That's why you subtract. So that's x to the third. This y to the 7th, do you see how it's positive?
Yeah, because
Well, it's already positive. See how there's nothing to even add or subtract it from?
Mm-hmm.
So you totally leave that alone, because that one's good. But this z to the negative 2, you can't have that. So to make something positive, you bring that z to the negative 2 up, and when you do, that negative 2 becomes positive 2.
Mm-hmm.
So that's how that one simplifies by subtracting 12 minus 9 with the x1s to get x to the third.
Oh, I thought you had to like...
No, because you can't, there's nothing to do, add or subtract with the y's, so you can't touch the y's. And then this, once you bring it to the top, there's nothing more you could do with it. Do you want me to give you one right away to try like this?
Yeah.
Okay, why don't you on your paper, why don't you maybe write down that answer for me, and then I'll give you another one to do on paper right now, and we'll see how you do. So I'm going to have you do one just like it. I'm going to give you an x to the 20th over x to the 12th y to the third z to the negative 4. Yeah, write down that first one first, because that gave us x to the third, z to the positive second on top, and y to the 7th on the bottom. Okay? All right, now try one here. I'm giving you x to the negative 20 divided by x to the 12th, kind of like you do for this one. And then the y1 you're leaving alone, and then that next one. Yep. Top power minus the bottom power.
So 20 minus 12. 10 minus 8.
Yep.
Is 1.
So that, when you take away that, that just gives you, like when I did x to the 12th, that just gave me x to the 3rd. So after all this work, you just have x to the 8th. Maybe write that right there. So perfect. That's the top of the fraction, right? Now the bottom of the fraction, like maybe draw a little fraction line underneath that. The bottom, you're going to leave that down there because that's going to stay.
Yeah, okay, right, because
It's already positive.
So negative 4. Wait, so what do I do with this then?
So remember on this one, when I add z to the negative 2, I bring it up, and it becomes positive when you bring it to the top side of the fraction. Now circle that right there. There you go. Good job.
Can you give me one more?
I for sure can. If I gave you, and this time it's y to the negative 2, z to the 3rd. So one of those you're going to leave alone, one you're going to move up to the top.
Okay, so I do. And then 8 minus 2. It's 6.
Yep.
Okay. So then oops.
When I would write it, I'm going to delete that and have you rewrite it again, because see how you wrote that 6 all nice and big?
Mm-hmm.
You want to write that 6 real small to show yourself that it's the exponent. There you go. That's the top part.
And okay, and then I do
the one with the positive exponent you leave alone.
So
the one with the negative you move.
So 2 to the 3rd.
Yep, z to the 3rd stays the
that's
same.
a z.
Yeah, that's my z. That stays because it's already positive.
Okay, and then y to the 2nd.
Good, because that was the negative.
Okay, I get it.
You think you understand that?
Yeah.
Sweet, good job, lady. Let's circle this answer. So if you want to go back in this video and ever look. All right, the next one is this guy right here. You have an exponent.
Oh no, I get that one.
You sure?
Yeah.
Because this
it
one,
goes both,
the way we like to do is maybe distribute that so that gives you 5 to the negative 3rd over 6 to the negative 3rd.
Mm-hmm.
And then you switch both, right? So when you switch it, that becomes 6 to the positive 3rd over 5 to the positive 3rd. That's one way of writing it.
Oh, then I might have done mine differently, yeah.
Another way is just like if you had 4 to the negative 2, you flip it and make that positive. You could do the same with this. You could put this whole fraction over 1. You could flip it so that 1 goes to the top, and this fraction 5/6 to the 3rd becomes positive. I mean, that's another way you could write it. But that's kind of tricky because dividing by that is the same as timesing by the reciprocal of that. So that's tricky. So I think on this problem right here, instead of doing it like that, the reciprocal way, we would rather you take this negative 3 and know that this 5 has a little imaginary 1, the 6 has the imaginary 1, times it. Negative 3 times this 1, 5 to the negative 3. 6, this 6 negative 3. And then anything that's negative that you bring to the bottom becomes positive. And anything you just bring up to the top becomes positive 2.
Okay.
Want to try one?
Yeah.
All right, what if I gave you 2/3 to the negative 3, let's go -2 power.
Okay. So
So I took that times it by both, remember? All right, there you go. You already flipped it, right?
Yeah.
All right, sweet. Let's see that. So it looks like you before you distributed, because I did the first step where I did this first, and then flipped it. You just flipped it, but that's still fine. I mean, that would be the final answer in the end. All right, you ready for the next one? What is any number raised to the 0 power?
1.
So it doesn't matter, right? You want to...
But then I'd flip it and then it'd be over.
Don't even got to flip it.
Yeah.
Nope.
What?
Nope. Doesn't
Oh,
matter.
it'd just be 1?
Just 1. Anything...
Oh, because it's the whole... I thought there
anything
was...
0 power is 1.
Okay.
If you have 3 to the 0 power, 1. You got a gnarly old fraction, 1/301 to the 0 power, 1. Any of this junk to 0 power, 1. Just 1. All right. How about these ones? You ready? All right.
Is this basically the same thing?
Kinda.
But what oh, that's 1.
Yep.
Oh,
so
I know this one, yeah.
you did that one?
And then I'd flip it, because
The
36 is...
The -36, that is a normal number.
What?
You don't touch it.
Oh, okay.
The only things you're gonna move up and down are these negative exponents. Do you see that?
Mm-hmm.
So this negative exponent right here, you can't have. This negative exponent you can't have. That -36, don't touch it though. That's just a plain number.
Okay.
So x -2 comes up to the top and becomes positive. Y to the -4 comes up to the top and becomes +4. So I think that would be like x squared y to the 4th over that -36. And again, you don't want to move that -36 because that's a plain number.
Can you give me a
100%? You got it, bro. Let's give you 32 x y to the 10th, all raised to the 0 power because they're trying to trick you into thinking it's nothing, it's just 1. And then on the bottom, I'm going to give you a negative number, a negative exponent, and then I'm going to give you one more exponent z with a positive exponent. All right, so try that one.
Hey. It'd be...
So anything to 0 power, automatic 1, doesn't matter what it is.
Okay, so I'm going to have to flip it anyway.
So what stays on the bottom? What gets
okay,
moved
so
up
I
to
just
the top?
like that. Okay. So Z4.
Yep,
Oops.
Z4 stays on the bottom. What else stays on the bottom?
Oh, 20. I forgot.
-20.
And
what moves up?
I don't have to like switch the whole thing. Okay.
Just the variables themselves. Perfect. And if you had to write that neat so you could see what the answer is, what would the answer be to that?
Oh, it would just
be that you do that. So
oh,
that
like
would
just
be,
rewrite it?
Yeah, rewrite it nice and neat.
Okay.
So that is 1x to the 2nd, y to the 2nd over -20 z to the 4th. Good job, girl. And the reason you didn't touch the -20 because it's a plain number. Don't move it.
I don't need to like switch the whole thing either, right? Like I don't need to like do the reciprocal.
Nope.
Okay.
For these, they're wanting you just to move stuff up and down. If you had like negative exponents, I mean, it's just, you're just doing moving problems. That's all you're doing right now. You're looking at problems like this, where you're like, let's see, negative exponents can't have them. So if you move them 10 stays. Y squared comes up to the top, positive now. X to the negative third comes down to the bottom, positive now. So those are that's what you're doing right now. All right, this guy, this one, this -2 distributes. And again, I think it's easier to know that this is 12 to the first power, and that 2 negative is going to times both by that 1 right there and times that 4. It's almost like you're distributing that all the way through. So that would give me 12 to the -2 to the -2 power. And now that is a number with a negative exponent. I'm going to have to move it. Where this number didn't have a negative exponent, don't move it. This one gives you x to the -8. And then you got to move stuff. You can't have anything negative, so that 12 to the -2.
Oh, because you got 8 because you did 2
Yep,
times.
I times.
Okay.
Because this is, when you have an exponent raised to another exponent, that's the only time you ever times exponents.
Okay.
So I times that times the 1, because any whole number is 1. I times that by 4, and now you're switching. The 12 to the -2 comes down to the bottom, +2 now. X to the -8 goes up to the top, now +8.
But can you give me like 1?
100%. Let's shrink this stuff down right here so we got more room. Let's put it right here. Let's give you 14 over x to the third, and I'm going to have you raise that to the -3 power. Good. Timesing by both numbers of -3 times that 3 and then -3 times that 1. Good. 14 to the -3 power, x to the perfect. And then we don't consider that simplified. We want you to move stuff around to make it be positive.
Oops.
Yep, so that becomes positive when you move it.
That's it, yeah.
Is that a 3 right there?
Yeah.
Yep.
I just did the plus.
I see it, I see it. Let's make that nice so you can see. Yep, so you distribute that perfect, and then you rearranged it, and now that became +3, and now this became +9, right? Do you want another?
Sure.
All right, here we go. Let's give you, how about you write it? How about 14, no, how about 18?
Oops.
Over
It's okay.
x to the 5th. Perfect. And I want you to raise that whole fraction.
Wait, oh.
Just like this. So put little parentheses around that whole fraction. And raise that to the -2 power. How would you do that one? Good. Good. And now simplify it. Make those negative exponents positive. Good. X to the +10 on top. Good job. What do you think about that stuff, lady?
That was easy. Yeah.
It's not. It's just you're smart. That's why it's easy for you. All right, let's keep going. Let's do these problems on a separate board. All right. Let's take a picture of that. All right, last 3. Or 3 more. All right, these guys are pretty much the same kind of problems here. You're doing alphabet soup. You're identifying right here. See all these A's right here? So I'm going to take the 8 minus 2 power.
Oh, so I minus it. Because,
Yep.
like, when I do, like, my other ones, you, like, usually, like they're not division. So.
Yeah, the only time you don't minus is if I would have been times them a to the, then you plus them.
I like those ones.
And then the other one, like we were just doing, girl, the other one is when you have an exponent to an exponent. That's the only time you ever times.
Yeah.
Everything else is either plussing, or if you got something like this, subtracting, right? Mm-hmm. All right, good job. So yeah, this gives you a to the what? If I do top power minus bottom power.
So 8 minus 2.
Yep.
It is 6.
Yep. 8 minus 2 gives me a to the 6. How about my b?
Oh, I see. Oh, okay. 10 minus 4 is 7. 6.
Yep. How about the c power 12 and 6?
6.
Yep. And that's it.
Oh, okay.
And you don't have to do nothing because you didn't end up with any exponents negative. Didn't have to do nothing. Maybe this one a little bit different.
Yeah, what happens if it's like negative?
Then you got to simplify and either bring it to the top or the bottom.
Oh, okay.
All right, so for this one, the 8, see that 8 right there?
Mm-hmm.
That 8, you're not going to move it.
Right.
You're going to leave that 8 alone because it's not an exponent. Or really, it is an exponent, girl, but it's the first power. And any positive exponents, you don't move them unless you're subtracting, right? So you're going to leave that 8. But the m, this is tricky. You got negative 6, and you have 3. What's negative 6? Take away 3. Top power minus the bottom power. So
wait, what? Am I doing 6 minus 3?
you're doing the top number minus the bottom
Oh,
number.
wait, but like, is this for m or like?
We're doing the m number.
But why is 3 over there?
Because this is on the end.
Oh, m. Okay.
We're looking at the m first.
Spaced out. Oh, so m 6 minus 3.
So it's not just plain 6 minus 3. It's negative 6 minus 3. What's that give you?
Is it 30?
That gives you m to the negative 9.
Oh, I'm adding.
If it was just plain old 6 minus 3, you would get just m to the third power, right? Just 6 minus 3. But since that power is already negative there, and you're always subtracting top minus bottom, that's why I did negative 6 minus that 3 to get negative 9. Are you seeing that?
Yeah.
Because this guy right here, this one, didn't have to worry about that because we just did 8 minus 2, right? 10 minus 4. We didn't have to worry about that. But if one of these, though, if one of these was negative, girl, then you would have had to do negative 8 minus 2. That would have gave you a to the negative 10 right there. Do you see that? All right. So this gives you m to the negative 9. What is my n power going to be?
Is 1.
N to the first. Am I going to have to move that around?
Yeah.
The negative 1?
No,
What about this?
Yeah, you have to move. No, not that.
What about this?
Yeah, you have to move that. You have to switch it down.
Yep. So if I switch it, what do I do? Where do I move it?
It'd be 8, and then it'd be n to positive
Good.
to the 9.
Positive 9. Good job, girl. And that n stays on top, end of the 1. And I have a feeling he'd just write it n. I mean, you could always write it n to the
He says we don't
first.
have to simplify it. Or, like, he said
Well, I
we
think he wants you to simplify if you have the same powers.
Oh, okay.
And I think he wants you to simplify any negative exponent. So I think he does want you to do that. Because what we did otherwise you're just leaving it. But yeah, simplifying it, top power minus bottom power, moving negative exponents down. All right, let's look at this one. Or do you want me to throw one at you?
Mm-hmm. You can throw it, for both of them.
This is like alphabet soup. This is where you're earning your money. All right, so let's give you a to the 10th, b to the 3rd, c to the 6th, over a squared b, c to the 4th. We'll start out with that one, then I'll make it harder. Watch out, right there.
Okay, so
top power minus the bottom power.
10 minus 2 is 8.
So that's going to be a to the 8th.
And then 3. Would that just be minus 1?
Yep,
Yeah.
that's a little hidden 1 right there. Yeah. It's going to be 2 to the 2nd. Yeah.
And then C is 6 minus 1. And 1, 2, 3, 4.
So now, what's the final answer look like?
That is A to the 8th,
To the 8th.
B to the 2nd,
Good.
and C to the 2nd.
Good job. Circle that. Good job, Lee. Good job. That's a generic one. All right. If I make it harder here, this is going to be a little harder because this one, some of them, when you subtract, are going to be negatives. Let's try to do this right here. Oops. Man. Sorry. Trying to get too fancy. Whoops. All right, good enough. I can't get that 8 in there for some reason, but all right, whatever. All right, this guy, I'm going to give you, let's use x's and y's. X to the 5th, y squared, z to the 4th, over x, y to the 8th, z squared. Try it out.
Okay. And
Good. So it's going to be x to the 4th at the end.
and
I'm going to give you a negative number.
what?
2 minus 8. What's 2 minus 8?
6.
It's not positive 6.
Wait, why is it negative?
Because you have 2 positives, and I'm taking away 8 negatives. So the 2 positives cancel 2 of the negatives and leave me excess negative 6 right there.
That's confusing.
Have you been doing your positive negative numbers?
Not in a while.
Not really? Okay, so that gives you negative 6. Z to the good. Now write the final answer. X to the 4th.
So am I gonna have to switch it again?
Yep.
Okay.
But do this first. Y to the negative 6. Z.
Oh, I don't know what I'm doing.
Keep going. Z to the.
Oh, 4th.
No, that was 4 minus 2.
Oh.
I think it's 2nd. Right. Now, which one of those needs to be moved to simplify it?
Y to the 6,
Yep.
negative 6.
This you're going to leave on top. This you're going to leave on top. But this is going to come down. So x to the 4th. Z to the 2nd. Over.
Y.
But when you bring that y down, is it still?
positive, sorry.
Yep, it becomes positive 6. There you go. Good job, good job. And let's write this nice and neat so you can look at it later. So you got x to the 4th, z to the 2nd, and then y to the positive 6. Good job, bro. All right, let's give you one of these guys. Let's give you m to the negative 4, n to the 5th, over 7, m squared, n squared. Try that one right there. Because that's just like this one where I did the -6 minus that 3. You're doing -4 minus that 2, 5 minus that 2.
Oh, okay. Wait, I'm gonna be adding, so. 4.
What are you adding?
4 plus 2.
So are you doing the top number minus the bottom number? Because isn't division always the top power minus the bottom power, right?
Yeah.
So are you doing the top number minus the bottom number?
Oh, I don't. Yeah. Oh, I don't know.
But you didn't write the first. You wrote positive 4,
Yeah.
isn't it?
No, I thought I was just like adding because like in this one we added.
No, this one I didn't add though. This one I took that -6 and I took the top number and I minus the bottom number.
Oh.
I subtracted -6, the top number, minus the bottom number. -6, the top number, minus the bottom number. And that was tricky because that gave me -6 minus 3 gives me -9. But look right here. When I did normal 3 minus 2, do you see how that's normal? 3 minus 2, that's where I got that 1 right there. But when I subtracted that number minus that, I got -6 minus 3 gave me -9. So you got to do the same thing. You're taking -4 and subtracting 2. Yep. That gives you 2 negatives combined to a bigger negative. That's -6 right there. Yep. Just like -6, take away this 3, gave me -9. -4 minus this 2 gives you an even bigger number, -6. But now do you know what I did? Because that -9 went on the m power. What do you got so far?
Oh, so m
To the -6, good.
and then I do m.
That you could probably do in your head, right? Because you're smart. What's 5 take away 2?
3.
Yep. So that just ends up being n to the 3rd power, right? Because you did 5 minus 2. Now what is on the bottom that doesn't move?
7.
Yep. So put that whole thing over 7. Now do you see something that can be simplified?
Yeah.
Yep. So bring that m to the -6 down. Still got that 7 down.
Oh yeah, I
there.
forgot. Sorry.
Yep. On the top, you still have
Into the 3rd.
end of the 3rd. There you go. Good job, bro. So just like this one, that was a problem. Just like that, Camille, you divided -4 minus 2. You got -6. That gives you m to the -6, n to the 5 minus 3. And then you left that 7 alone. And then you brought this down, right? Good job. So that ended up being end of the 3rd like you got over 7 m to the +6. What do you think? Just madness, right? All right, this guy. What's anything to the 0 power? 1. So this is 120 times 1. 120.
Oh.
They just, that's it. They're just trying to hammer home.
Yeah, okay.
Doesn't matter what that is. 0 power is 1. Could be a million, billion. 0 power is 1. Anything less is still 1. All right, let's take a look. And maybe, should we have you write some of these on paper? Because
I have all of them.
You have them? Are there any that we didn't do that are still throwing you for a loop?
Not really.
Can we just go through them real
Yeah,
fast and
yeah,
check
yeah.
your answers? When you did this in standard form, did you take this decimal and move it 7 places to the right? Because if I take 1.54,
Wait, I thought I was moving to the left.
nope, because this is positive 7.
Oh, I thought.
So I'm going to take that decimal and move it, because this is plus 7, I'm going to go to the right 7 dip-de-doo. So here I go. One.
I thought I was moving
two.
left to
Nope,
right.
only if it was negative 3, 4, 5, 6, 7. Where that last dip-de-doo ends, that's where the decimal goes. And I'm going to fill in zeros in these little dip-de-doos. So my final answer for that one, lady, is 154 with 1, 2, 3, 4, 5 zeros. Because you're moving it to the left. I mean to the right, because it's positive 7. Remember when we were doing these, sometimes you kind of forgot how many dip-de-doos you did, and you put like sometimes too many zeros in there. So you got to really, I really clearly counted 1, 2, 3, 4, 5, 6, 7. So if you did it the way I did it, you should have 1, 2, 3, 5 zeros in there.
Yeah.
You got that?
1, 2, 3, 4, 5.
Good.
Okay, yeah, I thought it was left to right.
If this was negative 7, you would have moved it that way. Right? But since it's positive, to this one right here, lady, did you put the decimal between the 1, the 3, and the 5? Because I think that's how they want you to write that. 1.353. And that would be times 10. And it'll count dip-de-doos. If my decimal was right here.
Did you get 1.353 times 10 to the 13th?
I know, I'm going to find out, because if I have my decimal right here, let's see how many dips it takes to get to the right. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Took 14 dip-de-doos. And you got to really be careful there. Let me just double check that, because sometimes, I'm doubting myself. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, it definitely took 14 moves. That's why it's 10 to the 14. All right, keep going. 5.12, lady. This one, you are moving that decimal to the left because that's negative right there. So if I move that 6 places to the left, 1, 2, 3, 4, 5, 6. This is where the new decimal is going to go. And I fill in 1, 2, 3. So it looks like this final answer is a real small 0.123450 zeros, 512. Real small number. Make sure your decimal's in the right. So I started here, 6 to the left. 1, 2, 3, 4, 5, 6.
And for the last one,
This one?
since it's like it's around so I just do okay.
Yep. Because remember, that number always has to be bigger than 1, but less than 10, right? But now the trick, girl, is to figure out the power on the 10. And it looks like it's going to be negative. So you ready how I do this? Maybe you could do it. We could check. So if my decimal is there, to get to its original spot, because that's where I put it in scientific notation, right? To get to its normal spot, let's count. It's going to be 1, 2, 3, 4, 5, 6, 7 to the left. So that makes that x to the negative 7 power. Yeah, because if you started here, 1, 2, 3, 4, 5, 6, 7. And you can see the only way you're going to miss those is if you're counting wrong or something.
What? How am I getting 8?
I don't know. Let me get my glasses. Oh shit. Glasses.
2, 3, 4, 5, 7. I'm getting 8. What the heck?
I don't know. Let's make this real. Let's make this
2,
bigger.
3,
So
4.
let's make this bigger. So it looks like I have 1 right here, right?
Oh.
So that's where I put my decimal for it to be in scientific notation. And then you want to count up here on the video? You count.
Yeah, I guess. Yeah.
You got 7?
Well, I was like doing it wrong. I didn't know you were supposed to do it right.
What were you doing?
I was putting it here instead of.
Oh, you were starting at between the 1 and the 7?
Yeah.
Yeah, you would have had an extra number than me, right?
Uh-huh.
But if you started really at the right place, 1, 2, 3, 4, 5. So yep, make sure you're starting in the right place. All right, let's move on here. Let's look at. Let's do that. How about this one? This guy?
Oh, I know how to do these.
You do? You times the
yeah,
numbers
you do.
normal. So
Oh,
1.08 and 9.3. You times those normal. This is a trick.
It doesn't matter how they're lined up, right?
Nope, not for times. Perfect right there. Good job, bro. So do that arithmetic. 1.08 times 9.3.
Wait, how do I? Oh, I do 3 times 8, 24.
Put a 4 right there. Carry the 2. 3 times 0 is 0. Plus that 2.
2.
Good. 3 times 1.
It's 3.
Yep. This place we got to put a 0 or an x. Now 9 times 8.
72.
72. So a 2 right here. And carry a 7. Maybe cross out that 2. There we go. Now you're doing, you just finished this. Now you're doing 9 times 0.
0.
Plus that 7.
7.
Yep. And then the last one, 9 times that 1.
9.
Yep. Add them up straight down. 4, 4, 4. Ooh, should be up 10. Yep. Carry the 1. Perfect. Now, do you know where to put the decimal? You have 3 numbers behind the decimal. Where are you going to put that decimal? Come on in. Come on in.
Oh.
So when your
Here.
final answer,
Here, yeah.
where would you put that? That would only have 1 number behind
Oh, wait,
the
no,
decimal.
sorry. Here.
That would only have 2 numbers behind the decimal. I need 3 total. Where do
Oh,
I do
sorry,
it?
here.
Yep. So if you do that, all that work right there, lady, that gives you 10.044, right?
And yeah.
But then what do you get on when you times the exponent? -3 and another -3.
6.
That gives you -6, right? But now here's a trick.
It's positive.
It's still -6.
What?
Yeah, because 2 negatives when you're adding them, because these numbers
Oh,
you
yeah.
times. But here's the trick. This is a hard problem, girl. Is this scientific notation?
No.
You would need the decimal right here to make that answer technically scientific notation.
Oh yeah, that's not. I don't know. That's weird.
But if you take your answer that you got, because all that work that you did when you timed those two numbers and you added these exponents, you had to take this answer and move the decimal here to get it in scientific notation.
Oh.
What does that do to you, this exponent right here? You know?
Oh, do you add it's 7.
You sure? Let's see. If I was here, I think I need to go, let's see how that works. I need to go 1 to the left. So yeah, you're right. That makes that go up. -7. Did you write that one down? That's a tough one. Those are
No, I
super
didn't
hard.
add it. I didn't add it.
Those are the hardest problems on your test because you have to times the numbers normal. You have to add the exponents, and then you got to look to see if your answer is even in scientific notation. Now, that's tough.
Okay.
Let's do another. If I do 2 times this 8.1 times 2 and 8.1 normal, I'll let you do your there. We're almost done. So 8 times 2 gives you
16.
16. Good. And then
Okay, and then I do 16.
0.2 times 10 to the
5th.
is it +5 or -5?
Negative.
Perfect. And that answer is beautiful, but is that decimal the way you wrote it? Because you wrote it 16.2 times 10 to the -3. The trickiest part to get an A on your test is that in scientific notation.
I have to move it.
You would have to put it right there, right? So if you wrote it as 1.62 instead of perfect. Yep. So after all that smoke clears, this answer is 1.62, not times 10 to the -3, but because you moved it, times 10.
When do I know I have to move it?
What's that?
Do you always have to move it like that?
You have to move it if after you times it, your answer still really isn't scientific notation.
Oh.
That's when you gotta figure it.
Okay.
If you would have times two numbers like something like this, then when I times 2.1 times that 3 right there, it just gives me a number already in scientific notation, right? 6.3, and that will give me times 10 to the 9th, right? And then see how this is scientific notation, don't gotta move it, right? But if I went back to this problem right here, girl, and I changed it to maybe like this number right here, maybe 3.1 times 10 to the 7th, then when you times those two numbers, just to help you with the arithmetic, that gives you 65.1 times 10 to the 9th. Is that answer in scientific notation?
No.
So I would have to move the decimal here to make it technically scientific. What does that do to my power for a positive
It
one?
bumps it up, so it's 10.
Because you have to move it over an extra. I'm thinking on this one, if I move it here, oh God, I can't. I gotta see one thing here, lady. If I do 2.5 times 10 to the -3, that gives me 0.0025. So if I move this decimal to the left, that means to get to this answer, I gotta move it just, ooh, you know what? For those negative exponent ones, girls, I gotta redo when you do those adjustments on those, for negative exponents, the negative number goes down a little bit. Like this one right here. If you're moving it to the left, this really goes down to -5.
Oh.
For negative exponents, moving it to the left makes it go down. If it's a positive one, makes it go up. But yeah, I think this is going to be -5. I think this one is going to be -2. I'm thinking on that one, girl. All right, this one right here, last one. If I'm doing this timesing, I'm going to take that 5, and that 5 gets that second power 2. So this is going to be 5 squared times 10 to the -10. And then that ends up giving you 25 right there times 10 to the -10. Here we go. Is that in scientific notation?
Oh, no.
I would have to write the decimal right here. If I move a negative exponent to the left, -9, it goes down by 1. Because that means you don't have to go all the way over. You have to go over just one less. That makes it, does that make sense a little bit?
I do.
Sweet. And then we did this one already. I'll just crank these out for you to double check on your video if you want. This -4 stays the same. And I plus the exponents.
Yeah.
This guy, this -6 and this 9, you times those normal. I think 6 times 9 is -54. And then x4 minus 2, when you add them, gives you x squared. Y to the 8 times 5 gives me y to the 13th. So check that answer if you're looking at this video later. This guy is 2 squared, 3 squared. I'm sorry, 3 to the 15th. You times it. So this is 2 to the first. That 5 is timesing by that 2. That 5 is timesing by that 3. That gives me 2 to the 5th. X to the 15th. I'm not sure if you want to see the do that. 2 to the 5th is 2 raised to the 5th power is 32. I'm not sure if he wants that. All right, this guy times in 3 and 10, 30. 30 times 4. If I times these 3 numbers, you're going to get 120. V to the, looks like 5, 10, 13.
You just add, yeah.
Yep. And then U to the 9. I think you got that one. And then we did these tough ones. This guy up here we didn't quite do. I'll do this one for you.
Yeah, 3 times 2.
3, 4, 6. This stays the same. And then you times this, because this is going to give me 9.
Oh, I thought you did 3 times 2.
Well, 3 times 3 is 9. I'm going to times that 9 and that 2 to get 18. A to the 7th. B to the 10th on that one right there. We did these ones. We did these ones too. We finished these, right?
Mm-hmm.
We finished those on this page. Right here we did more. All right. What do you think?
I got it, yeah.
Do you write down all of those, or they're all in that video that I'm
Yeah.
gonna send your mom right away?
I'll look at it.
Okay. Yeah, look at them, and then, yeah, can I write some of these on here for you?
I can do it when I watch
You
the
sure?
video, yeah.
Okay.
All good.
Okay. I'll stop that. When is your test?
Come on.
Tomorrow?